Today's lesson will be talking about function operations. We're going to be adding, subtracting, multiplying, and dividing functions, and then identifying the domain of the resulting function. The core concepts listed here represent our different options for adding, subtracting, multiplying, and dividing functions. What you'll notice is the way that the notation will be written is we'll be looking, if I'm adding functions, I might write it like this, f plus g of x. It just means that we're adding function f with function g. There's an example here. Function f is 5x. Function g is x plus 2. If I add them together, I just take the 5x with the x plus 2, add them together. 5x and x are the like terms, so we get 6x plus 2. That's our resulting function. We're going to do the same with subtraction, multiplication, and division. When we're done performing that operation, we'll also be talking about the domain. And you can read here that the domain we know is x values. Well, the domain of our resulting function, let's say 6x plus 2, is going to be related to the domains of both f and g from the beginning. So we look at our original functions. Whatever the domains are for the original functions will be the domain for the resulting function. Additionally, with the division problems, we also have to look and make sure that the denominator does not equal 0. So like in this example up here, we would have to make sure that x cannot equal negative 2. And so our domain would include numbers that are not negative 2. You'll see that when it comes up later on. Okay, so for the first example, we're given two functions. F of x is negative 2 times the 4th root of x, and g of x equals 18 times the 4th root of x. We want to find each of the following and identify their domain. So first of all, we're going to find f of x, or f plus g of x. So we're adding function f to 4th root x with function g, 18, 4th root x. And we know from things we've learned previous, if we have like radicals, we're allowed to add together. So negative 2 and 18 is 16, 4th root x. That's our resulting function. Now the domain has to be related to the domains of the original function. So in this first function, the domain, because it's an even root, I can't take even roots of negatives. And so x would have to be greater than or equal to 0. And because this is also 4th root of x for function g, x would have to be greater than or equal to 0. And so our resulting function, the domain is x is greater than or equal to 0. For f minus g of x, same idea. We're taking f function and subtracting the g function, which is negative 2 minus 18. They're like radicals, so that'd be negative 20, 4th root of x. That's our resulting function. And again, for the same reason as above, the domain will be all numbers, well, all x values greater than or equal to 0. The next one, we're doing f times g of x. So we're taking our f function, negative 2, 4th root of x, and multiplying it by the g function. And when we multiply radicals, remember the numbers outside multiply and the radicands multiply as long as the index is the same. So this will be negative 2 times 18 is negative 36, 4th root of x times x, which is x squared. Now, if we can simplify, we want to. Think about this x squared with a 4th root. It's really the same thing as saying x squared raised to the 1/4, which is the same as x to the 2/4, but 2/4 is the same as 1/2. And so x, what we have here, the 4th root of x squared, is really the same as x to the 1/2, which is just the square root of x. So we're going to come down here and simplify 36 square root of x. At any point in this video, if you need extra time to write things down, just make sure you pause the video and get that taken care of. So there's our resulting function. Now we just have to think about the domain. If we look at our original functions, it's the same thing as above. X has to be greater than or equal to 0. Even in our final resulting function, x has to be greater than or equal to 0 for our domain. Okay. Lastly, when we divide, f divided by g. So negative 2, 4th root of x. I don't need the parenthesis. I don't know why I wrote that. Divided by 18, fourth root of x. Well, what you notice here is that the fourth root of x and fourth root of x are exactly the same, so when I divide those, they're going to end up canceling out. So we have negative 2 over 18, which is the same as negative 1/9. I can't simplify any further, so that's my resulting function. Notice there's no x left, so technically this is a constant function. There's not going to be an input. It will always stay negative 1/9 as the output. Think about the domain for this one. Originally, the two functions, just fourth root of x and fourth root of x, have the domain x is greater than or equal to 0. But what we also need to look at is notice that when I divided by 18 fourth root of x, I have to worry about the denominator being 0. And so we actually have to say that x cannot equal 0 because the fourth root of 0 would be 0. We can't have 0 in the denominator. And so I'm going to go back over here and adjust my domain. If x has to be greater than or equal to 0, but x cannot equal 0, we should just say that our domain is x is greater than 0. Just a side note right here. What if we had, when we divided, something like x minus 2 in the denominator? Well, then what would make that 0 would be if x was 2. So we would say x cannot equal 2 as part of our domain. So just a side note there. So we're looking at whatever makes the denominator 0 is going to be excluded from our domain. Okay, moving on. We're going to use all of these functions to evaluate. Remember, evaluate means find the value of each of the resulting functions from example 1 when x is 16. So we're going to find what is f plus g of 16. So what that means is we're going to take our function that we got from f plus g, which was 16 fourth root of x, and instead of x, I'm going to substitute in 16. So 16 times the fourth root of 16 is the same as 16 times 2, because the fourth root of 16 is 2, and then 16 times 2 is 32. If we do the same for f minus g of 16, we get negative 20 fourth root of x was our function for f minus g. We're going to substitute in the 16. So this is negative 20 multiplied by the fourth root of 16, which is 2. And then negative 20 times 2 is negative 40. Our function for f times g was negative 36 square root x. Oh, this time we're plugging in 16 for x. Square root of 16 is 4, so we get negative 36 multiplied by 4, which is negative 144. Lastly, our function for f divided by g was negative 1/9. Notice there's no input, no place to input x, and so my result will just be negative 1/9. We can't evaluate when x is 16 because there's no place for an input for 16. Okay, number 3. Same idea, different functions. Given the functions f of x equals negative x squared minus 3x plus 8 and g of x equals 6x minus 3x squared, find each of the following, identify the domain, and evaluate. So we'll be doing 3 parts here. So first of all, to find the function f plus g of x, we're going to add the f function, negative x squared minus 3x plus 8, with the g function, 6x minus 3x squared. When we add polynomials, we add the like terms. So negative x squared and negative 3x squared will combine to be negative 4x squared. The negative 3x and the positive 6x makes positive 3x. In the 8, there's no other like terms with that constant, so plus 8. So there's our resulting function from adding f plus g. And then we want to identify the domain. Well, the domain is what inputs are allowed. Well, in a quadratic function, which both of these are, the domain is all real numbers. We can put any number in for x. There's no restrictions. And then lastly, we want to find f plus g of negative 1. This is saying evaluate when x is negative 1. So we're going to take negative 1 and substitute it into our new function everywhere that there's an x, and then do the math from there. Negative 1 squared is positive 1. 1 times negative 4 is negative 4. 3 times negative 1 is negative 3, and then plus the 8. Again, if you want to use a calculator for that, that's fine. Negative 7 plus 8 is 1. So check that we've done all of our parts. We've found the combination or the addition of the two functions. We found the domain, and we've evaluated when x was negative 1.